All right, up and running. Got some 1, 2, 3, 4, 5, 6 problems for homework here. You take your time with them. Obviously, pause the video. I'm just going to work through things. I think you know by now that I believe that math is a language. And if you don't know how to say something in a foreign language, then you got to ask somebody. That's the first step, is to just, oh, that's the way you say it. And then you got to practice it. You got to get out there and use those words on a daily basis in order for them to become fluent. The same thing in math. So if I ask what the element of 8 is and you don't know, then watch me do it and see if you can pick something up. And then hopefully I ask you another question like it, and you're a little further along your way to maybe doing it yourself. And who knows? Maybe you're in a classroom and you figure out how to do it and you explain it to a classmate. All of those things help you with your long-term memory and your fluency. But you can't answer a question unless you know what the question is asking. So each time, I hope you stop and pause and go, what's being asked here, right? And mathematics is all about commands, numerical commands. So what's element of 8 asking? You pause the video and try to answer it. What do you put on top of an 8? What do you put on top of E, which is 2.71 to get 8? What exponent do you put on top of 2.71 to get 8? Your brain's not going to do that, right? You're going to need a computer. You're going to need a calculator. But I'm giving you some of those values so that you can not have to push the buttons, right? They're all approximations. So we're going to do that first problem organically, and then we're going to use the rules of logs. All right, so organically, let's get started. Again, you pause when necessary. So 8. Well, I know that 8 is 2 cubed. All right, I got to work on this thing. So 8 is 2 cubed. All right, well, I know what 2 is now. 8 is approximately e to the 0.7 is the number 2. 2.7 to 0.7. It's really 0.69. It's like pi, but this is good enough. Bankers use the rule of 7. They use this rule, actually. And so I'm going to cube that. And so I can now see that 8 is approximately e to the 2.1. So I can come over here and I can answer it now, 2.1. Using the rules of logs. Well, the rules of logs are ln of 8 could have been written as the ln of 2 cubed. That's where we started organically. And then what do? You change 2. Well, you leave that, and you bring the 3 in front. Because that's what I did. 3 times 0.7. That is the ln of 2. And I'm multiplying it times 3. And so what is 3 times ln of 2? 3 times 0.7. Yeah, there's your 2.1. And there's your rules of logs. Okay? All right, so that's that one. Next one. ln of 72. Oh, God, this eraser. Oh, I shouldn't have been on this board. Oh, what a mistake. I'll put it up here. Oh, maybe I can get a better eraser here. I don't know why we went to those little blue terry cloths. This is a little better. All right, I might switch boards here in a second. Only got a couple to do. So we want to do 72 organically. Well, I know 72 is 9 times 8. And I know 9 and 8 are factors of 2 and 3. So 72 is equal to 3 squared times 2 cubed. Well, we just did 2 cubed, right? 2.1. We can do it again, though. So what is this? This is e to the 1.1 squared, and this is times e to the 0.7. Doesn't hurt to do it again. Cubed. Well, that's 2.2, and I know I add, when I multiply like this, I add, and that's 2.1, so my answer is 4.3. Let's do it using the rules of logs. The rules of logs state that the ln of 72 could have come from saying the ln of 9 plus the ln of 8. I hope you can see that 9 times 8 is 72, right? And that's where I did the ln of 9 the exponent to get a 9, and that's the exponent, the activity to get an 8. So what is ln of 9? ln of 9 is the ln of 3 squared. 8 is the ln of 2 cubed. And that is the same thing, we proved it in class, as 2 ln of 3 plus 3 ln of 2. And that's taking place right here. And when you do something like m squared times m cubed, you add 2 and 3. That's why there's a plus sign there. Because this is, I'll get rid of all the unnecessary writing. This is e to the 1.1 squared. This is e to the 0.7 cubed. And there's a multiplication just like that. So there's addition. All right, put some muscle into this. Now we'll do, so that answer was 4.3. So you would have put 4.3 right there. All right. Next one. And using the rules of logs. Okay, I think we'll just use the rules of logs right now for this one. They're there for the shortcut purpose. So let's do the shortcut. The ln of 9/4. That's a division. I know when you do division like this, for instance, well, you subtract. So I know that this is the same thing as the ln of 9 minus the ln of 4. And that's equal to the ln of 3 squared minus the ln of 2 squared. And so that's 2 ln of 3 minus 2 ln of 2, which is equal to 2, 1.1 minus 2.7, which is 2.2 minus 1.4, which is 0.8. Okay, so that's what that was. Now we're going to do 2 graphs. That's it for homework. Got to put this on a chair. I hope it's going to work. All right, so we are going to graph 2 logarithms. We'll graph this one right now. I hope, 5 or 6 hours since you had class, but I hope you remember the mantra. The mantra for logs is set the parentheses to 0, set the parentheses to 1, set the parentheses to the base. What makes a 0? 0. What makes it 1? 1. All right, so I've got to be able to do 3 log base 1/2 of 1 plus 7. And I hope you know that you get 7 without even thinking. What do you put on top of a half to get 1? 0. If this is 0, 0 times 3 is 0, and you get 7. So 1 gets you 7. I'll put that right there. Now I got to make this thing equal a half. Oh, then I'm just going to plug a half in. And if I put a half in, I get 3 log 1/2 of 1/2 plus 7. And your brain should be able to work for that. That's 10. All right, so a 1/2 gets us a 10. 1/2 is between 0 and 1. 10 is above. So 1/2 gets us 10. And there we go. So that's the inverse of a exponential decay problem, because 1/2 is cutting things in half, right? So that's the inverse of that. All right, one more problem. A nice short, sweet homework, and hopefully you give it some thought, and you hopefully are getting ready for a test too. So what's the mantra? X minus 5 over 6 equals 0. X minus 5 over 6 equals 1. And it's a natural log, so the only difference here is I like to set it to 1.1. I find that generally easier to work with. And I said the wrong thing, I apologize. It's easy to be dyslexic. I want it to be 3 because the ln of 3 is 1.1. Okay? It's easy to make those misstatements. And I just made one, but I have corrected it. So when you're dealing with ln, set the parentheses to 0, set the parentheses to 1, set the parentheses to 3, and your brain should work. What makes that 0? 5. That's your domain restriction. There are no points on the curve unless you pick an x value bigger than 5. So I'm going to pick 11. 6 times 1 plus 5. If I put 11 in here, I get 4 ln of 1 plus 7. This is asking the question, e to the what equals 1. I hope you know that this is 0. Anytime you get a logarithm with a 1 in the parentheses, you get a 0. 0 times anything is 0. Again, you get what's at the end there, 7. So what did I pick? An 11 gets you a 7. I'll put a dot here. 11 gets you 7. Now I want it to equal 3. So 6 times 3, 18. Oh, I can do it better here. 6 times 3 is 18, plus 5 is 23. 23 is way out here. 23, now I just got to find out the height that goes with 23. So I put a 23 in and I do the math. 23 minus 5, 18. 18 divided by 6, 3. What's the ln of 3? 1.1. So I get 4 times 1.1 plus 7. That looks to be 11.4. 11.4 is bigger. So I get 23, comma, 11.4. That's out here somewhere. Boom. So what's happening? My y values are always getting bigger, but less quickly so. Always getting bigger, but less quickly so. That's your trajectory. All right, so that's your homework for tonight. And also study the answer key from your last test because we're testing again on Friday.